So welcome to the MongoDB introduction session. This session uh, is the first session of the class, and this is a free session for everybody. In this session, okay, let me first introduce about what is KnowBigData. So KnowBigData is an online training uh, instructor-led training mechanism whereby instructors from the industry who are the experts in the big data domain, they come online and give the talks. Okay, and most of these sessions will be held on weekends between 7 to 10 in the morning or 8:30 to 10:30, or maybe on the weekdays in off office hours uh, for each day for 2 hours. In this way, all the people who are planning to switch their career, upgrade themselves, and get acquainted with the new technology, or big data enthusiasts, they can join and attend the sessions. Okay, so the first objective of no big data sessions is that people should be able to ask questions and I should be able to answer. Because there are hundreds of videos available all around the world on the same topics, but the only reason people join our classes is so that they can ask questions. Okay. And okay. So second objective of no big data is that the lifetime access to the content, whatever these sessions are, we are going to put on the recordings of those online so that all our members can access the content anytime. And all the materials like presentation, like various kinds of homework assignments, everything will be available online along with the detailed documents about each topics. They will be available online, and you shall be able to access all those. And there will be an hands-on training whereby I'll provide you an access to the cluster, as well as I'll give you the pointers to the virtual machine which you can download, and how do you install it and run it, that I'll guide you. Along with that, I have purchased around 8 servers on the cluster so that everybody can telnet to that machine, and on the real cluster they can try it out. Okay. So, like for example, MongoDB in general is installed on around 8 computers minimum, so that you can really explore how does it work in a networked environment. So I'll be providing a 8 computers cluster somewhere in the on the internet, which you can access from anywhere. Okay. And then I'll be providing 24/7 support. I have built a team here who will be, providing you the 24/7 support, because the students in our class are from all around the globe. So so that we have to be up 24/7. Then at the end of each project, we provide a real life project, because I have been working on big data for quite some time in the industry. So I have been acquainted with various kinds of real life project. And the other teammates also, they are into the similar industry. And so whatever problems generally a company faces with respect to big data, we will be providing those kind of projects. and the public data sets. Public data sets such as the astronomy data which is available publicly, or say for example Enron's data. Enron was a company which was public listed, and after they went bankrupt, their data was made public. So you can churn that data and see the insights. So that is quite interesting. And then there'll be at the end of this session there'll be a certification test, and this certificate, it will be available publicly on your profile. And also at the end of all of these during these sessions, we'll provide various kind of quizzes which you can test whether you learned it or not. Okay. And based on your quizzes and performance in the real life project, the certificate will be provided. And then there'll be basically these will be 8 sessions, including today's. There'll be 8 sessions, 3 hours each class, and there'll be a 5 minutes break in between. Okay, so this is little too heavy, the 3 hours class, but this is the optimum use of people's time, because this is only happening on the weekends. Otherwise, the course will not finish ever. The next most important point is the socio-pro visibility, as in your professional and social visibility, that you have learned something. So what KnowBigData will be doing is KnowBigData will be providing you a LinkedIn recommendation based on your performance in the class, and it is up to you whether you want to accept that recommendation or not. And similarly, will be whatever certificate we provide. If there is some company who is asking us that did this person really attended a class here, then we will be providing your certificate to them. And if you are okay with that idea, then at the end of it, we are also planning for the mock interviews for each topic, because lots of people who are on the board of big data, they have been conducting interviews for various kinds of positions like analyst, and they are also in various kinds. Just a second. Okay. Actually, in the between, people join in. Okay, so we will be conducting the mock interviews on each of the topics which we give the training on, and there'll be more like what industry expects out of you. Okay, and the only reason why we have started KnowBigData is because in the industry as of today, most of the instructors are not the instructors who actually were hiring people for big data requirements. So I had built a team, and I have known lots of people during my Amazon, InMobi, and other times. So I thought that out of all the people I have met who are giving online training, my team was far better placed in the sense of working on the big data, because the term itself, big data, is quite cliche, and everybody is trying to take up advantage of it. So and most of people did not even know that how to use these technologies in front, and still they were giving training. So I thought I'll start it up with a proper training framework. Okay, so moreover, I had been giving training on MongoDB and Hadoop for more than 5 months now, though I have been training people all my life during my career, other than building products. Okay, so I'll just go through my profile quickly. I had been working on big data during my D-Show times, just that we did not know that it's called big data, because we had around 20 terabyte of data being generated every month at D-Show. D-Show is probably the biggest consumer of big data since 1980s, and we had a distributed network of around 10,000 computers in 2000s. So lots of things we were churning data in and out. At that time there was no Hadoop, but we had similar but inefficient framework. Now I think if we could have got idea like Hadoop, it could have been better, or MapReduce. Then I founded Tbits Global, where I was working on a similar to MongoDB, I had built a document management system which we sold to large organizations such as L&T and everybody. Then I took an exit and joined InMobi, and during InMobi time was the most interesting time, where I was I churned around 200 of terabytes of data to give the recommendations to the users. And then during Amazon phase, I had built a high throughput systems for their Amazon.com website. So I was taking care of first Amazon.com website, and then I was taking care of their mobile app. So, and we had done a lot of innovations, and most of the backend at Amazon, the interesting part is Amazon is the founder of these NoSQL databases. They published a DynamoDB long back. And most important part is that they still are using RDBMS. So they have figured out that there is a need, and for every need they had tried to map the right solution. So the merchant data is still in Oracle, while the data about products, data about images, data about people's feedback, and all of this is inside our NoSQL databases. And we have actually moved ahead from DynamoDB, which we published long back, to a newer system, which is similar to now what MongoDB is. So okay, just a second, let me check if there are more questions. Okay, so no questions yet. Does anybody has any questions right now? Just feel free to put it on the chat box. Just feel free to put it in the chat box. There's a group chat session. Bhagwat is asking, can we see other people's question? Frankly, I have no clue, because I am using Hangout for the first time. I had been using GoToMeeting most of my time, and probably I'll revert back to GoToMeeting from next session onwards, because there were more than 100 signups. That's the reason I've used it. Umang's question is, hey Sandeep, do we need Java background? I am a Microsoft guy all my life. No, Umang, you don't need Java background per se, because all of these technologies are mostly language agnostic. And with respect to what these technology, whatever is required, I'll guide you all through. And all you require is, if you have been with respect to MongoDB, with respect to the MongoDB database, this whole training, what you might require is that you should know a Unix or a command prompt anywhere. You should be able to edit file and run various commands. Second, you should be acquainted with any programming language at least once. Only then you will be able to understand a MapReduce paradigm, for example, or aggregations. Okay, okay. Great. So people are able to do group chat. The only thing is those people who have joined in. So if you have not joined in, I have also sent you invitations directly. If you click on them, probably you can join right away into this group chat. Otherwise, you'll be watching this through the YouTube, and from there, I'm not sure if you can see the discussion. Okay. Now let me get back to the. So enough of flaunting about myself, and let me just start with the course content. So this is like 8 sessions which I am planning. First one is about introduction. Introduction with respect to with respect to big data. Introduction to NoSQL. An introduction to Cap Theorem per se, and MongoDB in general. I'll also show you a hands-on if time permits in this session. And then we will, in the next session, I'll be sending you the installation guides and the link to virtual machines and how to access the cloud, our cloud. And then we will, talk about other how to insert data, update data, all those basic operations with which you can get started with MongoDB, so that when I talk about various kinds of things, you will be very comfortable. The CRUD operations means create, retrieve, update, and delete. That is in the second session. Third is about data modeling. Data modeling as in, there is a paradigm shift. We had been using the databases in a certain manner. Now this database requires a little different kind of mindset. For that, you might have to, model your data a bit differently to take a best advantage of it. And it gives you basically that another way to look at data, unlike your relational. And here in the third one, I'll again give a quick architecture overview. And in the fourth session, we will be discussing about administration and security. Administration and security will involve how do you secure your MongoDB, how do you add various users, give them permissions to do various kinds of things. Okay, and how do you, if you are adding more servers into your network, what do you do? If you are removing certain servers from the MongoDB network, what do you do? So those kind of things will be taken care in administration and security. And then we'll talk about how do you index and aggregate. Okay, there might be a shift in these orders. There might be a bit of shift in orders because I'm actually fine-tuning my syllabus. So it might be that fifth and fourth are switched, but nothing to worry. I'll keep you updated. Okay. Then in the sixth session, I'll be giving you a very detailed architecture overview. And that's why I've taken a whole 3 hours class for that, because this is what is very much required. If you are no clue about architecture of MongoDB, then you might end up not using it. And then we will talk about the project work assignments and replication and sharding. And in the eighth session, I'll give you a hands-on demonstration on how did I set up my cluster, the cluster you had been using all the while. Okay, so and this will give, I'll give you, in a nice manner, how do you from one point to another, setting up each node and then connecting them together and then distributing data across all these nodes. So I'll give a nice demonstration on setting up cluster, and then we will have a review of what we have done so far. And after this, there will be 1 week of time to complete project work, and then we'll have a we'll assess the project and then give grades accordingly. Okay. Great. Let's move ahead. And then we have okay, so today's class is about what is big data and why do we need such kind of why do we need big data in first place, and what exactly is the problem with big data. Then what is NoSQL, why do we need NoSQL, and what are the types of NoSQL databases available, and a quick summary of NoSQL versus SQL databases. And then I have put it again, NoSQL versus SQL, and then Cap Theorem and base I will explain, and I'll try my best to explain it in as simple words as can. Then what is MongoDB? Then replication and sharding with respect to MongoDB. Here I'll give you a quick architecture review overview, And then I'll give you various other feature description of various other features of MongoDB, like GridFS and MapReduce aggregation pipeline. And then I'll show you a hands-on demonstration. Okay. Okay. So time to start. And just give me one more second. I'm getting more questions. Hello. Great. So big data in a very simple words means data of very big size. And how big? It's so big that you can't use your traditional tools to process it. It is as simple as that. So in general, when the data grows to a size of say 1 terabyte to 1 terabyte onwards, it starts becoming difficult to process using your traditional tools. The moment you reach 1 terabyte of size, your SQL queries and everything becomes almost impossible to use. And if you further keep on moving, it's not linear way your tools behave. Okay, if your server was taking 5 minutes to process 1 terabyte of data or 1 GB of data, the moment it reaches 2 GB, it won't be 5 minutes. It will be more than that. Okay. So, and IBM came up with the nice definitions of these things and tried to describe what is a big data. So big data, I mean, the same thing what I have said, data of big size, and they have tried to formally say it in this manner that the volume should be huge. The big data is characterized by volume, the velocity, the rate of change of volume, at what rate the volume is increasing, and the variety. Variety as in earlier we looked at mostly the transactional data as data. But now videos, photos, music, and binary files, everything is counted as data. So that is variety. These are various kinds of data, and we vaguely categorize data into structured, semi-structured, and unstructured data. We'll describe you later. And then veracity, when the data is in doubt. So they themselves did not know the definition. Okay, so then look at this chart. So basically, why did we need big data in place? The answer is simple, because more people got connected, more people got more devices, and hence people started generating data. And some of the people thought that restoring all of this data will be quite useful, and hence they ended up a lot of data. And I mean, everybody having devices, internet connection is generating data at all the time. Like this hangout is being recorded and all the chats are being stored. So we are actually generating data. So everybody at every point of time started generating data the moment we had more devices and we had more internet connectivity. So if you look at 1986, analog data was around 2.6 exabyte. Some people did some study, and the digital was quite small. Can somebody answer what is an exabyte? Great, great. Adesh is saying exabyte is 10 to the power 18, 18 bits of information, 18 bytes, not bits. Anybody else? Anybody else? Bhagwat says 1000 terabytes. No. 1000 terabytes is a petabyte. Okay. Okay, let's move ahead. And yeah. So, and as you can see, the data has just exploded by 2007, and it's growing really, really fast. So there is no other way for organizations to say that we don't care about data. We don't want to store or process it. It has become uh, you know inevitable. It has become inevitable. Like earlier, people were giving 5 MB of inbox space, but now organizations cannot turn it down, that we won't give that much of space, or because it has become a common necessity. So the next point is, what exactly is the problem with big data? Lots of us seem to assume that a computer can actually do everything in fractions of seconds, but that's not the case. That's not the case. Big data is the point where that limit is actually reached, where we used to look at computer that everything can be just finished in fraction of seconds. And in case of big data, that doesn't seem so. Okay, I'll describe you why. So there are four basic limitations or four basic needs of processing or storing a data. First is you need a big hard disk, which we all know. We need a bigger disk space. So, and second is we need a faster hard disk. That's why the SSDs are replacing your old, basically the magnetic drives. And third one is we need processor. Okay, so processor is something which need to process the data, the microcontroller or the processor. And fourth aspect is RAM. Okay, RAM, we talk about two things. Like one is bus speed, the rate at which we are reading from the RAM, and the size, the how big the RAM you're using. So you can only process the data, like say you want to do certain operation, you can only process the data which is at the RAM or at the hand at the time. Okay, so the size of the RAM becomes the major constraints in any kind of huge load systems. That was the first thing which, first limitation which people encounter, the size of the RAM. Say for example, if you are building like Wikipedia, so they encountered the RAM as their first limitation when they started handling the load. Disk space was okay. Disk space was okay. Read write was okay. Processor was good enough, but RAM was the first constraint. Okay. So let me ask you this simple question. If you have 100 terabytes of movies, 100 terabyte is not a big deal. 100 people, if you have 100 friends and if you gather movies from all of them, you will get 100 terabytes of movies. How would you store these 100 terabytes of movies? Let me ask this question. I'm seeing in the group chat, so feel free to write down there, or on the chat message. If you have 100 terabytes of data, how are you going to store it? Others says that it's in the hard disk, but you don't have 100 terabyte of hard disk. Okay, probably people are typing the answers. Bhagavad says several nodes, but yeah, right. So Ade says that with the capacity of 1 terabyte of hard disk, we will keep 100 such devices in the to store this. But you cannot connect 100 devices to a computer. So you need to have the distributed network. And Ajit, master slave disks, it's not possible to actually connect 100 terabytes of data. There's a bus limitation on the motherboard, and it will be impossible for one disk. So Bhagwat is and Adesh are quite close, where you have 100 computers. Okay, okay. So Bhagwat, do you see any problem? So do you see any problem with this approach? This is what you wanted to say, right? So we have hundreds of, I mean, that's what Adesh also says, hundreds of 1 terabyte of drives, and make 100 subfolders and mount these from the network. This is how we used to do traditionally. Okay, 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 okay. So yeah, so your answers are right. So the biggest challenge we face with respect to such an approach. So the what is the approach? You take 100 computers, just imagine 100 computers or 50 computers, connect two hard disks each, and mount all of these hard drives into remotely into a folder. So you will have 100 folders containing all of this hard disk space. Now, what is exactly the problem with such an approach? The first problem is what happens when one hard disk goes haywire. We all know that hard disk failure is not uncommon. It's just part of life. So if you have 100 hard disks, it's very much probable that every second day you are going to lose a hard disk, or every third day, because the lifespan of a hard disk is around 2 years or 3 years on an average, nothing more than that. So every second, third day, you are going to have a hard disk failure. So are you going to lose your data? If you are not, then you might need a backup system, and the failover also. Failover as in if one hard disk fail, other one takes over, who has the mirror of the data. So that's not possible in such an approach. Now, say you are dividing, your files are in 100 folders, and you have kept movies starting with A in the first one, B in the second one, and so on. And then you realize that there are so many movies starting with S, and that's when you say, oh, my whole scheme of mapping of movies with respect to folders is wrong, and I need to make S1, S2, S3 as multiple folders. So this is how we describe a data uniformity, or dividing your data uniformly across the network, which is very difficult thing to achieve manually, and it requires a lot of time to do it. And third is this the best value for money? We talked about 1 terabyte hard disk. We all have some 500 GB hard disk, 250 GB, 60 GB. We all have those lying on our desks. And why can't we just use those? Okay. So, and 1 TB hard disks are costly. So, is this the best value for money? Are we using our best resources? Are we utilizing what we have right now? What about increased accessibility? We were fine. We increased this network. We set up this network of 100 1 TB drives. But what happens when all of your friends want to also watch movies from this file system? They will say that I'm not able to, view this movie. Are you using it? And then you say you watch it later. I'm finishing this movie. This becomes so accessibility goes down badly if you have single such network. So these are the 5 problems we did not address properly by using the above solution. And so what is the solution then? The solution is either you use a system like NoSQL or a file system, distributed file system like HDFS. Okay, let me have a look if anybody is having question. Okay, so if anybody is having question right now, let me know before I move ahead. Okay. Okay. HDFS, Bhagwat is asking, HDFS means it's a distributed file system. What we have just described, connecting so many hard drives in multiple computers and connecting it, forming a singular file system. That's what HDFS does for you. All of these 5 points which I discussed, HDFS or Hadoop distributed file system is the name. Uh, gives those functionality to you. Okay. Now, so we talked out of these four parameters, we talked about first two, and let's talk about the other two. So the other problem with big data handling is the processing. Let me ask you this simple question. How fast can 1 gigahertz processor sort 1 TB of data? So let me rephrase it. Imagine that you have names of 10 million people. Each name is 100 character long. Okay, so each name is 100 character long, and you have 10 million of such names. And it's I mean, it is quite common. It is quite common. Okay, say you are even Indian population is quite higher than 10 million, so it's not a big deal. So not 10 million, 10 billion we are talking about. So you have a 10 billion number of strings or names of people. Each name is around 100 bytes of 100 characters of characters long. So how long will your normal computer take to sort it? Sort as in order these names in ascending or descending order. Okay. How much time do you think it is going to take? Quick. Just give a random guess. Just give a random guess. Okay. So let me rephrase the question. If you have 1 gigahertz processor and you have to sort 10 million strings of 100 byte each, how much time do you think it is going to take? Are you with me? Adesh, Bhagavat, and Ajit, Irapa, Samta, Shreya, Umang. Okay. Umang says it's 1,000 seconds, which is less than an hour. No, just Bhagavat, I'm just checking your checking if you what does your gut instinct says. If you have 10 billion of strings and each one is 100 character long, yes. Ajit is saying couple of hours. Adesh is saying 3 to 4 hours. Anybody else? Great. So out of all, Ajit and Adesh are quite close, as in as in it takes around 5 hours. It takes around 5 hours. So it simply says that 5 hours is actually not acceptable. As simple as sorting these 10 billion names. I mean, it takes more than 5 hours actually. And it simply says that we need a better processor, and processor has stopped growing faster. Moore's law, which stated that every 6 months your processor will become twice as faster, has failed badly for past 3 years. Okay, since 2011, processors have stopped doubling. All the people are trying to do is bundle multiple processors together, Core to Duo and all those things. Okay, so Moore's law has failed. Earlier, we had a hope that processor will keep on growing faster. So we can't really, if we want this sorting to finish before 5 hours, we don't have, a solution that we will get a better processor. And third one is RAM becomes bottleneck. You know why does it take 5 hours? Because we can't fit all that data into the RAM. Okay, so what we do generally is, say you have a 10 GB of size of RAM. So we slice this data into 100 pieces and load each piece one at a time into the memory, and then order this data, and then put it back into the disk. And we keep on doing it. And that is why it took 5 hours of time. Okay. And also your disk read will matter here, because we are reading the data from the disk and writing to the disk back and forth, because we can only process a small chunk of the data. So the RAM becomes a bottleneck. Okay. So we talked about processing. I count RAM as part of processing because if RAM is low, processor does not matter at all. If RAM is high, then the processor is quite fast as of today. Okay. Now let's move ahead. Similar problem. Let me just restate what I told. So why I asked sorting or ordering is because ordering is part of every analytics game. As in, say you want to write a query like select star from XYZ, group by certain column. So this query itself is using sorting multiple times. Okay. So sorting is the basic problem of computer engineering. And similarly, in this problem which I've said, you have 200 terabytes of data containing who played what game on their mobiles. Okay, this is the exact problem I actually solved it in Mobi, but with a very different set of users. So, and you have to find top 10 mobile most popular games. Okay, so you are Android and you have a information that who is playing what games, how many times, from what time to what time. You have all of this data, and you have to find top 10 most popular games of all time. And just imagine that you have a network containing 200 hard drives, and doing all of this for you. Basically storing all of this data in the file system. Okay, and you have to find out 10 most popular games of all time out of this data. Okay, let me rephrase. There is a data who played what game, and that is stored in like 200 hard drives in your network, or 200 computers. You are given 200 computers containing each 1 terabyte of such information, and you have to find out what are the top 10 most popular games of all time. What is it that you are going to do? Quick. Anybody? Should I rephrase the question? Okay. So you are given this data in plain text file. Imagine that Ajit played Temple Run, Ades played Fruit Ninja, and and Bhagwat played Angry Birds. Such kind of data of lots of people, and it also contains repeated data, such as based on how many times did you play the game. And this data is of size of 200 terabytes. So what I did was I divided this data into 1 terabyte each, put it on 200 computers, and gave you access to these 200 computers. And you have to give me at the end of day that what are the 10 most popular games as per this data. Okay. So you have 200 such files containing first column containing name of the person, second column containing name of the game, and third column containing what time did the person play the game. Now, based on this, you have to tell me that what are the 10 most popular games of all the time. How would you do it? Okay, okay. Ajit says that multiple search process jobs, put it in temp result, then process the temp result to get the final. Almost you're close. So you just have to, fine tune your answer a bit. And okay. Ade says that create a key of using all three columns. Okay. But why do we need the third column? Third column was arbitrary, the timestamp. Okay. Okay. Bhagwat, what's your point? Umang, Shreya, Samta, Irappa. Okay. So the question is that you are given a list containing say imagine Excel sheets. Let's just for time being assume that you have Excel sheet which can handle 1 terabyte of data, which is actually not possible. It can't even handle 1 gigabyte of Excel sheet. I mean, after 100 MB, Excel sheet starts crying. Okay, so let's just imagine for time being that your Excel sheet can handle 1 TB of data. So you have got Excel sheets, uh, each containing 1 TB of data, in the sense that first column is the name of the person who played the game. Second person, what is the name of the game? Okay, name of the game as in Fruit Ninja, Angry Birds, and all. And you have got this data stored on 200 computers in the network. And now you want to find out what are the top 10 most popular game of all time. It's a very simple thing if you look at from the analytics perspective, the old way of doing things. It's a classic thing of using SQL. Uh, select top 10 from a database. Okay, and select distinct top 10 or select distinct game name, and then at the end of it you put limit 10. That's it, you are done. Okay, so we were pretty happy with that kind of setup, but the moment we had this big distributed data, we couldn't do it anymore. Okay, so such a simple thing becomes a complex exercise. And yes, Irapa, first 14 slides are sort of over, but the whole video is recorded, so you can watch it when you are free. Okay, so but we have just covered a lot of theoretical aspect, and you can watch it again. It's all recorded. Okay, so say you have 200 terabyte of data. Okay, okay. Ajit, you have actually advanced. Ajit is saying that uh, is asking for map and reduce. Okay. Yeah. So that's what was my answer. But let's just have a look at the other existing traditional way of doing things. So the first rudimentary way is that we have already split the data across 200 machines. On each machine, find the frequency of the game, as you said earlier, and then merge the data by summing the frequencies of each game on each machine. And then after merging, just print out 10 data. Now, there are a lot of problems associated with this approach, although it looks very easy. The problem with this approach is that the data after you have merged, the biggest data, is so big. Even after merging, you will have to sort the data again, and that's where the problem would start. Okay. So the solution in very simple words is uh, any system with MapReduce or any distributed system should be able to solve your this is the basic problem. Okay, so any NoSQL database such as MongoDB, we should be able to solve your problem. Okay, and this is the kind of thing Google compete all the time. In 2008, using 1000 computers, they were able to sort 1 TB of data in 68 seconds. The problem we pointed out in second step, where we are merging the data and data is so big, so that requires sorting again. So sorting, Google has solved around, I mean, very nicely, and that this 68 second has also come down further. Okay. So the conclusion of the 4 points we said: big disk space, disk read write speeds, processor speeds, processor power, and RAM. It can only be solved as of today by using any distributed system where we utilize thousands of computers to solve our problem in time. Okay, so such kind of thing is solved by Hadoop and other NoSQLs very well. There are lots of systems which have come into place. Okay, now I am starting with NoSQL. Before that, I would like to have some questions. Okay, so looks like people don't have a question. Either I'm not explaining anything or I'm explaining something very well. Either of the two. Great. Great. Thank you, Samta. So, okay, I'm happy that I'm able to explain things. Now, let me start with what is NoSQL. Okay. And this, remember, this is an overview of the whole game, of the whole big data uh, technologies. This is the overview of the system. It is not a deep dive. I'm trying to, inculcate the need of why people need big data, why people need to solve the problem, and why it is important for people to understand why, how it is done. Okay, so I'm trying to, go quickly over the complex topics. Okay, so now let's start with NoSQL. NoSQL in simple words, this is a comic. So if you have no expertise in SQL, you can write I know NoSQL. Okay, and probably that's the reason this term was coined. Okay, so so if you want to update your resume and you don't know anything about SQL, you can write that I'm NoSQL. Okay. Okay, so let me start with what is a NoSQL database. So as we said in the previous slides that we divided data across the network. So people divided the data in terms of key value, basically two column databases and across the network. And whenever they needed to join it, they'll just join it. And whenever they wanted to join it, they joined it based on keys. So they divided the whole data into key value pairs rather than multiple columns. First column is always a key, and second one is a value. So that's where the NoSQL was started. Okay, that was the point where Amazon came up with DynamoDB, and they started because there was the traditional approaches were not working. Okay, so the rudimentary way of starting was a simple key value pairs. So, and after that, lots and lots of innovation happened, and there are, I mean, hundreds of such databases have come into the industry. So, first, NoSQL, the word itself was coined very quickly, just to signify that they could not write SQL for this database. SQL as in they could not use standard query language, structured query language. So they said that we just call it NoSQL. And those guys who were building this, they were running for a seminar and they wanted a handle, Twitter handle for NoSQL. So they just created a handle called NoSQL. So that is how this name was coined, and people call it with various names such as not only SQL, new SQL, or simply NoSQL. Okay, it's a new generation of databases, and second point is it's not only SQL, it is more than that. Then it's non-relational, as in the data is not adhering to the properties of relational databases. The properties of relational databases are mainly the transactional, transactional and kind of tuple algebra they should follow, which is not there. So it's not the relational algebra, uh, that chord theorem and everything does not apply here. That is why it's called non-relational. And fourth thing is it's a distributed architecture. So this is the most important aspect, that it is distributed architecture, because of which it happened to be non-relational, because it was not possible to I mean to stick to the relational properties. Okay, so because the data was spread across the network. Okay, data was spread across the network, and we needed a way to join the data. So when the data got spread out, it was not possible to stick with the transactions and other properties of a relational database. Next important aspect of a NoSQL is almost all of the databases as of today are open source. Open source as in the source code of all the databases are available. Okay. And if you wish, you can start making contributions. Contribution in terms of making changes in the code, fixing them, and even fixing manuals. And also, there's a huge, because of being open source, you get a great community, you get a beautiful support from all the people across the world. And NoSQL databases are horizontally scalable. Horizontally scalable as in today you are not able to cater to the users with 5 servers. You add one more server. Rather than upgrading your 5 servers by changing their RAM or changing their processor, instead you put one more server in line and make it 6 servers instead of 5. And had you been, upgrading your servers in the sense that you will go and increase everybody's hard disk and change the RAM or change the processor or change the hard disk from normal to SSD, that is called, if you try to do all of those, if you try to upgrade the hardware, that is called vertical scalable. So earlier we always followed a vertical scalable model where we will upgrade our servers when the new hardware comes into market. We upgrade our servers, throw away all our old ones or put them into non-critical use. But nowadays, the trend started with Google, where they started buying old hard disks from their university and then started connecting them together. So that model where you keep on adding more and more new machines into the network rather than upgrading existing is called horizontal scalable. Let me have a look if there are questions. Okay, good. Good, there are no questions. And then schema free, because it's non-relational, so it's not required that you create a table up front. Okay. Or if you are creating some database impose, some NoSQL impose table creation, but it's not necessary to create a column and you define the data type of column and those kind of things. It's not necessary. It's not necessary. And then easy replication. Easy replication as in it's basically you need not to put any extra effort to replicate your database. Say your one machine goes down, you need to move the data to another one. There should not be any other effort involved. So replication is part of almost every NoSQL because all of these are designed for distributed architecture. So replication is part of the whole, part of every NoSQL core. Every database has the easy replication. Simple API, yes, it has got a very simple API. It has just a create, retrieve, update, and delete. Those are the basic aspect. But it grows complex when more and more features are added. Okay, but they are trying to have a very, very simple API. They are trying to keep it extremely simple in the sense insert, update, delete should be very, very simple. You don't need to have new kind of syntax every time. Okay. Now, next point is that manage use data. Yes, that is the sole objective. And then commodity hardware. As I said when discussing about Google, so they were buying very, very low-end hardware rather than buying blade servers or high-end edge servers. They were just buying the commodity hardware of people and attaching it to the network. So that's a philosophy followed by everybody in the industry, where we build these networks with a very low-end computers, just that we attach more and more computers to the network. Then Commodity hardware, as in you get your PC assembled in the market. Okay, like a black market, you can get that assembled. And for that matter, when we were working at InMobi, and I had to have a network of some 100 computers, so we actually bought from a local dealer. Okay, and set it up instead of talking to companies like Dell, or talking to companies like Sun Microsystem. We actually set up the uh, whole cloud using the commodity hardware as we buy for our house. Just that we did not buy any graphics card or keyboard or displays. Okay, we did not even have a sound card, or any other multimedia parts. We just bought a commodity hardware from the shop, and we just connected it in the network, and it was just working fine for around 2 years. Okay, then we moved it to the outside country, and there are more than 150 NoSQL databases. So in very simple words, NoSQL is a non-relational is a distributed database which help you in managing large data, and is non-relational, and it's not only SQL, as in it does not adhere to SQL. And there are lots of support in industry, so people can actually set up a NoSQL database cloud at their homes. It's as simple as that. Now, why NoSQL? Almost I've covered every part of it. Big data, of course, this is the basis of the whole NoSQL revolution. Second, agile. So when we dealt with the relational databases, we had to, even if we have to introduce a new field, and we say we want to take one more field from the user input, we have to change the schema. And while changing the schema, we have to also ship the upgrade script for the database, and we have to apply all those patches to the databases. That whole mechanism was fine until recently, because earlier the whole shipping time was around a year. When you are launching a new product into industry, you always launch it after, you used to launch it every year, once in a year types. And Microsoft used to launch it once in 2 years or 3 years. Similar was the Oracle. So that in those cases, the psychology was that we don't change or ship anything so soon, because the hassle of upgrading, or all of these hassles combined together, was too much of an effort. Okay, so in today's world, you cannot live with that, where you have to ship your product every monthly. Okay, so to have that kind of thing, you need to have your databases or the programming language which are quick to deploy, quick to build. And NoSQL comes to a very nice help, because while you are adding one more attribute to your object, you don't have to change the whole table schema or impact your whole business process, because it is schema free. So it becomes quite agile. Second, your objects are not stored as relational, so you don't have to do all that magic. So I said object oriented programming. So here, if you guys remember, if you guys have used Java or any other programming language, when you were saving the objects into database, so at that time, you always ended up using systems like Hibernate, where you have to flatten out your objects into relational model. Okay, so that was too much of task. You have an object, hierarchical object, which has sub-objects. Sub-object can have further objects, and all of those need to be flattened out. So it is similar to taking a square-shaped object and putting it in the round gap. And this is exactly was the problem of impedance mismatch. But NoSQL solve it very seamlessly by letting you store objects as is, and letting you search on various parameters. You can search for objects, sub-objects values, and that's something which is very interesting. Okay. Fourth aspect is high availability. Okay, high availability as in when you are handling a lot of load. In today's time, if you're launching, say, a simple product like form submission. Okay, so in form submissions, you have got 500 users, and all of these 500 users will sign up actually on the just last minute of the last date of submission. Okay, even though you have just got 500 users, your availability shoots up very high. Okay, in the sense that 500 users per second it becomes, because everybody will submit their form just on the last minute of the last date, and that's where the availability comes into picture. I remember discussing with a couple of my clients at when I was launching my own company. So they could not even get a form submission in their college just because they could not provide availability. And availability used to be a very, very big challenge, just because either database froze when you have 1 million queries in a 5 minutes window. Almost every database freezes handling that. Okay, so but NoSQLs come for that, basically that kind of attitude to handle big data and big number of requests. Scale out architecture. This photo, if you see here, this photo, it shows that we have added lot of kettles into the cart. And let me count. 4 plus 3, 4 plus 4, 8, 16. So the total horsepower you're getting is 16 horsepower. Had you added an elephant instead of all of these cattle, you could have only got 2 horsepower. Okay. So this model is called scale out architecture. And tomorrow you need 2 more horsepower. You can add two more buffaloes in the front, and you can keep on increasing it. So this is the ideal example used by the guy who created Hadoop and distributed architecture to tell what does it mean by scale out architecture. You do not wait for your kettle to grow big, or you don't buy a bigger kettle. Instead, you just add more animals into the same cart to pull it. Okay, when you have to handle more load. And here is one thing. Wait, let's just get back. So now till now we talked about big data, problems associated with big data, and then we talked about what is NoSQL, and now we are moving on to the various kinds of NoSQL stores. Stores is equivalent to saying databases. So basically, there are 4 kinds of broad categories in which we have categorized NoSQL. First one is column-oriented databases, whereby they look like our traditional database tables. This is the dream of everybody to reach to that direction, where people are able to query these databases using standard SQL. Okay. While some other databases, such as MongoDB, they are document-oriented, in the sense that they have realized that most of the programming languages are object-oriented, and an object represents the data better than a flat table structure. In today's time, where you deal in non-transactional data more, in those cases, you use a document-oriented database. These are the examples of document-oriented database: Couchbase, MongoDB, and MarkLogic and ClusterPoint. And then the third kind, they are the first primitive kind of databases called key value. That's where the whole idea about NoSQL started. So somebody came up and said, we are not able to manage our data using relational. I could not build something better. So what I have done is I have just stored key values in various files, and I have built a database around it. That's how the whole game started. So the first one to do this was Dynamo, and then Redis, then Memcached, and all sorts of databases. But interesting part is whether it's column oriented, document, everybody is having a key for the row. Okay. Unlike our database where it's optional to have primary key, it's optional to have a primary key. In case of these NoSQL, every row has got to have a key, because since it's distributed, the distribution happens based on the key. And that's the reason why each of the NoSQL is supposed to have a key. Similar to what we have in object-oriented programming, a pointer which points to an object. Okay. In the similar manner, we have a key which always is unique across all the objects in a particular table. And table is named as other kinds of things. So let's have a look at what does it mean by an object. So object I am using interchangeably with document. Document does not mean a Microsoft Word document. It means an object and a complex object. Okay, let's have a look at the photo on the right hand side, which says that TV shows, there are many TV shows has many seasons. Every season has many episodes. Every episode has many reviews and many cast members. Okay, so this is a complex structure to represent TV shows. Okay, so if you have to do it in RDBMS, you will be creating at least how many? 3, 5, around 10 tables, because one table for the values and one table for the mappings. Okay, so and here you will be just creating one table containing all the TV shows and sub-object, sub-sub-object inside that. Okay, that is what is a document-oriented database. While in I missed to describe this photo. In column-oriented database, they look like database table, but each row is not bound to have the same set of columns. Okay, unlike in our database, every row when we are putting values, you have to put some value or null in that row. So like if you see in the photo, the first photo, if you see here, first row is having one column, second row is having two column, three columns, and third one is having two columns, and it can vary. Every row can have different set of columns, but that does not mean that you insert, all kind of database data into the same table. Each row can have different set of attributes, but it does not mean that you just put completely different objects together. It is just a functionality which is provided in order to accommodate a slight bit of changes with respect to each object. Okay, this is a flexibility given to the people, and this comes pretty handy. This comes very handy when you have, say, an object which is inheriting some class. Okay, now there is another object which is inheriting the same class, so you can actually store these two kind of objects into the same store. Okay, unlike earlier, it used to become a very difficult to accommodate even a single column difference. Either you keep on putting nulls, your half of the table space is gone. But in this case, it's quite easy and it does not waste any space in case of our NoSQL if your rows have different set of values. In normal SQL, it wastes a lot of space. You call them sparse tables. Okay. I'll just have to mute somebody. Great. And because somebody just logged in, so everybody is logging in by default in a unmute mode. Hi Ritesh Negi, and although it's middle of the talk, it's not a problem. So we were describing what is NoSQL, what are the different kinds of NoSQLs in place. We talked about two NoSQLs. One is column oriented, whereby they look like traditional tables, but each row can have each row can have different set of column values. Second one is a document, where we try to store the document objects. And third one is a key value pair. They are plain simple vanilla values. And okay, okay. So Bhagwati has got a very good point. He says that could you use an example for these types? Okay. So column oriented, we all know the whatever we were trying to manage using traditional SQL, we generally follow the same approach. So here there is no confusion at all with when you are managing using column oriented. So column oriented, there are three I know. One is Cassandra, other is HBase, and one more. So column oriented is standard, like an Excel sheet where you keep on putting values. The only difference is each row is supposed to have a key. Second, each row can have different set of values than the another row. Although they belong to the same table, they can have different set of values. This is a functionality provided in order to accommodate minor differences between various objects, various rows. And this is quite useful. But and most important part with respect to column oriented is that there are drivers available for all of these databases which can give you complete SQL kind of functionality, as well as when you are using with the programming language such as Java or Python, Perl, or any other programming language, you get a driver which you can just replace with the standard with the previous driver. So just by the changing of driver, you can start storing the data into NoSQL instead of changing all of your code in order to accommodate a new database. Okay. And column oriented, the big table from Google is also column oriented. Okay. Now second point is the document one. So first one, there is no confusion, right? Okay, column oriented. Cool. Now let's talk about document. So say you want to store all the TV shows, the information about TV shows. So in the standard mechanism, what will you do? First, you look at this photo. It shows you there are TV shows. TV shows has got seasons, and season has got episodes, and each episode has got review, and each episode has got cast members. Okay. I will describe you in detail when I move forward, because this document we are going to discuss in detail. Okay. With respect to key value pairs, each row just have two columns. One is key, other is value, and both key and values are generally strings, characters. Okay. And so when you have to store objects in key value pair, what you do is you start naming your keys as A.B.C. So you will be storing TV shows dot seasons dot one dot episode dot reviews equals this, reviews dot one equals this value. This is how you are going to store this data into key value, which becomes a very huge headache after a point of time. Okay. Also, querying becomes a very tricky thing. Now, fourth database which we are talking here is graph-based database, where nowadays after Facebook has come up with such a highly structured connectivity of between people, between various information. Similarly, if you look at the Google Maps, there are roads, there are intersections, there are buildings, and there are all sorts of traffic information. All of this is represented as graph. Okay. If you look at this diagram on the right hand side, it shows how Facebook stores the information as a map. So there is a person who likes something, And this is the map representing a typical Facebook graph who is located at certain place. And when you're querying such information, you cannot go with the relational algebra. You have to use graph techniques such as finding a path, finding people near you, who are at one distance, and other complex queries. If you have to do, you cannot stay with your relational database. These database, NoSQL databases, which are graph oriented, becomes very handy when you are dealing with graph of larger size. If graph is of a smaller size, it is easier. And to be very open about graph databases, if you are writing any algorithm related to graph by yourself, it is generally in the quadratic time. Meaning, if 100 people, if finding the map between 100 people was taking 60 minutes, okay, the the querying of 200 people is going to take 4 hours, not 2 hours. So most of the graph algorithms which people write are actually very uh, resource intensive, and that's where the graph database come into use. Okay, so out of these 4 databases, we will be discussing document oriented database, which is MongoDB, which is quite popular in industry and is quite useful. I'll describe you why it is useful and the various features it provides. Okay, so I'm moving ahead. Okay, before I move ahead, I want to get the questions, because we have got 1 hour left, 1 more hour left, and we have got some 17 more slides, 15 more slides. Any other questions till now you have? Great, great. Let's just move ahead. In very simple words, this is the analogy between. Just a second, I'm getting emails. Okay, great. So let's talk about NoSQL versus SQL. So the people, almost as I looked at people's profile and we were having discussion, almost everybody is aware of what is a SQL database. So it's good to have a look at it, the comparisons. There is generally one type of SQL database, which are almost everybody follows relational algebra, relational mechanism, where there are tables, there are databases, there are columns, and then you can query based on column values, and you can sort and group. In case of NoSQL databases, there are different kind of databases, as I described 4 broader categories just now. Then the development history. SQL databases have been developed in 1970s, and Oracle was founded before 1970s. While NoSQL, the first of NoSQLs which became public was in 2004. Then uh, then the examples of SQL databases. Examples of SQL databases are we all know MySQL, Oracle, Microsoft SQL, Postgres, and lots more. While NoSQL databases are examples are MongoDB, Cassandra, HBase, Neo4j, DynamoDB from Amazon, and Bigtable from Google. But those are proprietary, so those are not available to the public. Data storage model. In case of SQL, it's relational, and in case of NoSQLs, it's different. It's different. And schemas, NoSQLs have no rigid schema, but standard SQL databases are almost all have the rigid database schema. you have to define the data type upfront. But in case of NoSQL, the schema is dynamic. Scaling is vertical, as in when we have to perform better, when the load increases, we have to upgrade the hardware. And scaling is horizontal in the sense that we have to, instead of upgrading hardware, we just add more computers to the network. Development model is generally mixed with respect to SQL databases, while it's open source for all NoSQLs. The standard SQL support ACID properties, as in the transactional properties, okay, and which is we all know, right? So, and with respect to NoSQLs, the transactions are at the document level versus the transactions you have to, there are customizable transactions. Okay, I'll describe you why there is a difference. I'll describe you in a couple of minutes. Then data manipulation using SQL is state SQL, but here there are different APIs and different command lines that I'll describe soon. And consistency can be configured for strong consistency SQLs, while it depends on product. Depends upon, in case of MongoDB, it depends on how you are querying it. If you want consistency, you take consistency. Otherwise, you just consistency is something you put in your query. When you are querying database, then you put in the query key, I want the results to be consistent. I'll describe the definition of consistency in a minute in the next slide. So before I move forward, I don't think anybody is having questions. So at this slide, you will have lots of questions, I'm sure. So here we discussed in the previous slides that NoSQLs do not guarantee ACID properties. Okay, they do not guarantee the transactions per se. So why is it so? Why is it that NoSQL databases which are distributed are not able to adhere to the ACID properties? The reason was given in by one of the researchers called Brewster, Brewestr, that in terms of CAP theorem, out of the three things, consistency, availability, and partition tolerant, you can only get two, not all three. Okay, so what does it mean by consistency? Whenever you are putting data into the database and you are getting the data, retrieving the data, it should be exactly what you have written. It should not be older version. If you are getting older version, we call it database is not consistent. Since you are getting the data which is older than what you just put, or say I am putting data into a table and you are retrieving it. I just put it 1 milliseconds before you retrieved, and still you got the older data than what I put. So there was a value called the name was say cap in a database. We have put it somewhere as cap. I overwrote that value with hat, while when you retrieved after me, you still got older value as cap, not hat, which means that the data is not consistent. So this property of the database to provide exactly the data what the person who wrote just before you is called consistency. Okay. Now the second point is availability. Now in case of availability, it's a guarantee that the server is available. If there is a request, it has to be answered. This is called availability. Can we guarantee that availability? That's the property of the database. Now third one is partition tolerant. Given a network structure, given the resource, say you have n computers connected to a database who are serving. If you delete any of the nodes or disconnect any single node, it should not make your database database unavailable. Okay, so if your database becomes unavailable on killing one server, it means your system, your database is not partition tolerant. So these are the three things. First, consistency. You got what you wrote. The second, availability. The system is able to respond to all requests in time. Third, partition tolerant. Even if one server goes down or one hardware goes down, the system is still available. This is the more number of servers you can kill without impacting your whole database, or the more hardware it can tolerate, the missing hardware it can tolerate, the more partition tolerant it is called. Okay, so Knapp theorem says that none of the database in the world can provide all these three at a time. We are not talking about SQLs alone. We are talking about anything, any database in the world cannot guarantee all these three things. Okay, you can also think about in your real life, if you are trying to do all these things together, you want to respond in time, you want to be consistent, you may not be able to cater to each and every request you get. So this is what Knapp theorem mathematically tries to prove, that you cannot give all these three things. You can have only two out of these three things. And this diagram on the right hand side shows you what are the various kinds of database who lie in what zone. So big table lies between consistency and partition, but not availability. And so none of these databases which give this idea lie in the center where all these three things are overlapping. All these three circles are overlapping. So this is more or less Knapp theorem. Let me also show you one more diagram. This diagram. So there was this machine. A user was trying to write while B user was trying to read. Now this is a single machine. So whatever this guy is writing, he will get, second one will get that answer very, very quickly. And hence the database is called consistent and available, because whatever request one person sends, the other one will get. Okay. Now let's have a look at the second diagram. Second diagram. So the first one gives you consistency, availability, but not partition. Why not partition? If you kill this server, right? If you kill this server, you are not going to have the read and write anymore. So this is not partition tolerant. I told that even killing on one hardware, if your database is still able to respond, that means it's partition tolerant. If your server burns down, if your hardware goes haywire, still your database should be able to respond. So in simple words, your partition tolerant database should have more than one computers attached. Okay, at least more than one computers attached. So first one is not partition tolerant. Now let's have a look at the second one. Second one is, in the second one, let me describe what it does. So this person on the right is trying to write the database to one server, which is getting that replicated to another server automatically, and then the person A, the first one on the left, is reading that data. So this is what is happening. So this person is writing the data, and here it goes back. Now look at it. This person wrote the data here. It will take, say, 1 minute to come here, and then it will reach this person. So if there is a difference of 1 millisecond between this person, the person A, the person on the left, will keep reading the older data for next 1 minute, and then it will receive the new update. And hence this kind of structure is called inconsistent. This kind of structure is called inconsistent. Okay, but this structure, this architecture is able to respond to the people's request, because if one server gets deleted, this person will start reading from the first one. So it's partition tolerant, and it's available in the sense that when the all the time there is no bottleneck with respect to resources. Okay, now let's move to the second diagram here. In the second diagram, there is a single server on which there is a which everybody is reading. Okay, so this one is consistent but is not available, because when it starts reading and start writing to the replication system back, if this server on which the data is being written to, if it is goes down at any moment of time, it will take a lot of time between the request between flipping the replication server to the main location. If this server is going down, it will take a lot of time for this to come up here. Second, during that time, these request and response are down. Okay, so this is what an architecture which is consistent but not available. Also, this resource is always scarce because people are writing to it and reading from it. But this is partition tolerant in the sense that if one of the this server is deleted, the system is still keep functioning. So this is what says in very simple words, you cannot have availability and consistency all together. Okay, you cannot have availability and consistency all together. If you want to have more availability, you would like to go for more machines, and hence there will be no consistency at all. So what people have settled down for is a server which can provide you a trade-off. When you require consistency, you can get the consistency, but not the availability. It should not be, it should be up to you. If you are trying to access a transactional data, you should be able to put a consistency in place, and then you write the data with saying this data need to be consistent. While almost other time, if you don't specify that flag, you will get inconsistent data. If in most of these NoSQL databases, it is okay to live with a little older data. Okay, it is okay to live with the older data. That's where the same guy told about base. It's called basically available. Basically available means the server should be basically available even if it is consistent after a point of time. Okay, meaning the data will be updated to all the servers correctly in a 5 minutes of time, but the server should be available. You should be able to access the data. So let me explain you in other words. Even if while searching on Google, you get a little older website, okay, but you should get results. So that is the whole philosophy behind basically available, and eventually consistent databases. So the availability has taken a priority over consistency, and consistency is tunable. The moment you need database, say you are writing a financial data or reading a financial data, there you demand consistency, and database should be able to provide. MongoDB guarantees that kind of thing, where if you demanded consistency, it will give you consistency at the cost of availability. While you are writing this set of columns, this may not be available to the other requests. Okay, so this is another base compatibility theorem which Brewster came up with. It is opposite of acid, and it was actually, now consistency. All the SQL databases are with strong consistency, while NoSQL databases, it depends on the product. In case of, and most of the NoSQL databases, they have settled down for eventual consistency or a theorem called Bayes theorem. We'll come back to that in a minute. And data manipulation in case of NoSQL, it is through the object-oriented API. When we talk about, okay, CAP theorem. Here, when we were talking about our supports transaction part, here it says acid, and here it all depends, right? Which means that the kind of consistency, I mean, kind of transactions or kind of uh, acid properties which SQL databases were promising, NoSQL databases are not able to promise those kind of transaction properties. None of AC, ID, that all of those four properties, the NoSQL databases are not able to provide. And why is that? Okay, why is that? So Eric Brewster came up with the theorem called CAP theorem. You have three things: cap, consistency, partition, and then availability. Out of these three things, only two can be promised, not three. At most, two can be promised. At most. Okay. All three cannot be promised by any databases. Right? Now, let me first define what does it mean by consistency. Consistency means that when you write the data and read the data, uh, I mean, no matter how do you read this data, whether, I mean, so you just wrote a data and you're trying to read it just after a half millisecond, no matter what, you should get exactly the data you wrote, or somebody else wrote some data, you should get exactly what they wrote, just a half millisecond before you. Okay, so that is called consistency. Okay, now second part is availability. Availability means a guarantee that every request from the user will get a response. Okay, that is called availability. Every request from the user will get a response, whether it was successful or failed, but they should get a response. That is called availability. It should not get unanswered, or people should not, their connection should not drop at all. That is, if you are able to provide it a complete guarantee of the service, then you are saying that we are available. Our server is 100% available. Now, partitioning tolerance, meaning in case one of the nodes go down in your network, can your system still survive? So out of these three things, you can only promise two. Okay, that is what CAP theorem says. Consistency, meaning what you got in reading what you actually wrote. You got what you wrote. Okay, exactly what you wrote. Okay, there is no change at all. You are not reading older data. You are reading what you just wrote. That is called consistency. Now availability is uh, basically, even if one, I mean, availability meaning that every time this request should be answered. Okay, it should not be either timeout, or there should not be any kind of connection drop or too much of wait. Okay, that is called availability. If you are waiting in the queue, that's also hitting on the availability. Partition tolerance, as in there should be two computers. I mean, there should be more than one nodes, and even if one of the nodes in your network go down, there should be somebody to take care of it. Now, this is too much of theory. I'll show you a couple of diagrams that will make it very easier. Now think about a system in which there is only a single node, single computer. the person who is reading from it and writing from it, okay, it's only reading from the same computer. There is one person who is reading, the other person is writing. Both are doing it on the same computer. Okay. Now, it might be quite consistent, and it, but it is not partition tolerant. Meaning, in case this computer goes down, both of these users will go angry. They will not get any data, read or write. So that means it is not partition tolerant, and also the system is not really available. Meaning that one person is reading to a file, so other it that if a person is reading to a row, writing to a row, then the other person will not be able to read from that row, which means that row access is not available for some time, and hence it's not greatly available system. Now let's think about another system. Another system, second one, which has got two computers. Okay, every writes are going to the right hand side one, while the reads are happening from the left hand side one. Okay, so the user who is writing to the data will write to this computer here, and the reader will read from it. Can you guys see my cursor here? Okay, okay, great. So the writes will happen to this machine, reads will happen from this machine, and in the meantime, the data will go from here to there. Now, this system is really nice, meaning that it has got availability. While one person is trying to write, the other person is reading the data happily. Partition tolerant. In case the second server goes down, the first one will start reading from the reading from this first one, or this one goes down, he will restart writing the second one, which means that there is a decent enough partition tolerance. But imagine that this guy just wrote a data now, and just half a millisecond another user tried to read the data, same data, but from another computer. Now this, till the data reaches from first computer to second computer via replication, this guy will keep on reading the older version of this data, or will keep on getting no data found, because data has not reached here. So this system is not consistent, because people are not able to get what they wrote. Okay, no, they are not getting the latest state of the data. That means this system is not consistent. Now you did a smart thing. Now what you did was, the read or write is happening on the same machine, while there is a replication which is mirroring this system to another one. Nobody is reading writing to this one. Now this computer becomes the complete bottleneck. The way the first one was, this also becomes a bottleneck. And here in the first one, availability is questionable. I think this is neither available nor partition tolerant. Here, this network is partition tolerant, but is this system is completely bottleneck in the whole scenario, because if one person A tries to write, the other person will have to wait in the queue, and that is why you cannot guarantee C, A, P, all three at the same time. So were you able to understand what do I mean by that? Okay, great, great, great. So most of the people are basically fail to understand cap theorem. That's why I drew up this diagram, which actually works well. Okay. So this diagram basically says that you can only guarantee at most two things. In this network, you can only guarantee two things: availability and partition tolerance. And here you can only guarantee uh, you know, consistency and partition tolerance. And here you can only guarantee consistency. Here this is availability is also not there, because this guy is the bottleneck, and partition tolerance is also not there. Okay, so that this is what it is, right? So in the way, in case of MongoDB, it will be a combination of these two models on the right hand side, where there will be these kind of model and this kind of model. So most of the databases have settled down to base. Base is basically available. Okay. Just a second, something is gone wrong. Yeah. Okay, in third not getting. Okay, let me explain. Should I go back once? This third one, right? In third not available. Okay, okay. Right here. Here. All right. When we say not available, what does it mean? Because when both of these persons are trying to read or write from the same machine, so that machine is becoming the bottleneck. Or there is another bottleneck which says that when person A is also writing to the same row as person B is reading from the same row, so the writer will have to wait till the reader finishes. Okay. Or other way around. So one person is blocking the other one, and hence the system will become unavailable in case of load. In case this load increases and there are multiple people who are waiting, so there are high chances that this will not be able to service all the request in time, or service the huge number of requests. And that is why such kind of system where a single machine is a bottleneck will become the right. That's what I was saying, that there is a, here you need to mark it. Here there is, I need to mark it non-available also. The first one is neither available nor partition tolerant, right? Okay. So Wahid question is, then what is the use of second system? This one is the most tolerant system. Okay. You might get a little stale data. Okay. You will use this kind of system where you don't require immediate consistency. Okay, what is the use of this system? That's what is Wahid meant. This one is just a replication, it's a copy of this. You will bring it to the life only when this goes down. Okay, nobody is reading or writing from this one. Okay, we will see all these architectures later also, nothing to worry. Okay, so this is not, nobody is reading or writing from it, and this guy is the bottleneck. Okay. So these are basically very oversimplified diagrams to explain the cap theorem. Okay. Now let's talk about base. Okay. Now so when we say that we cannot adhere to acid properties, so Eric Brewster, the guy who gave the cap theorem, came up with a funny name called base. Base is opposite of acid. Okay, which effectively says this diagram. If you see this one, which base is effectively this one, meaning basically available and soft state and eventually consistent. So the only thing you need to remember is eventually consistent. So this system is not right away consistent, meaning the data, this change which is made on this machine will take some time to reach to the second machine, and then this person will read. And in this duration, when the change is being transmitted, this system is inconsistent because it having stale data. It is it is giving out the stale data. Now, so just to say that most of the NoSQLs are are adhering to the philosophy of eventually consistent. Okay, in the favor of being available, they all are eventually consistent. So, and I mean, base is exactly saying same thing, that we are basically available. Our machines are basically available. Soft state, as in the state is changing over the period of time because it's moving to the eventual consistency, and they will finally become consistent. And that's what is base means. So m- most of NoSQL databases, they mean the they need they mean to adhere with the soft I mean base theorem. Okay, now let's move on. Now we are starting with MongoDB. Till now we were generally discussing, we first discussed about what is big data and the definition, giving out two problems based on storage and processing, and then we discussed about NoSQL databases, and now we are going to talk about MongoDB. Okay, so in MongoDB, when we talk about a MongoDB, it's basically a NoSQL database which is document oriented. It's basically available and eventually consistent kind of database. It's open source and it is document oriented. Document does not mean Microsoft Word document. Document means a, a object oriented way of storing data. Okay. So when we create document is of this form. It starts with the curly brackets, then there is a key colon value, and value could be an array of values, or value could be further another object, and so on. Okay, so this is what it is. So document, you need to, before putting it into MongoDB, you need to format that into a proper JSON document. JSON is what? Can somebody oh, okay. So how many of you know what is JSON? Yes. So Wahid's question is that, does it support images and videos? Yes, it does. It does support. So you can form the your document in the form of a binary JSON format, and then you can store it in. Now here, okay, come just a second. Let me read Kamlesh's question first. Kamlesh, how does it store data for images or videos? Okay, in by yes, yes. So to store the images or the data, there is a format called BSON format, binary JSON format. So using your program or API, you convert that into BSON format, or MongoDB provides you a command line utility called MongoFS, using which you can store very huge files onto the database. Okay. Now let's have a look at how does a document look like. A document typically looks like this. My name is Sandeep. I have got a skill which is an array of strings called MongoDB Hadoop. I like music. Music, what kind of music? An array of artists. And then no sports, it's an empty array. Then education is this, and so on. So this is a standard way of structuring your JSON format, right? And remember the curly bracket. So whenever we say object, it's basically curly brackets. And whenever we say array, it means square brackets. And whenever we say name and values, it means name is a string and value could be any of this. Okay. Except for numbers, everything else has to be inside the double quotes and so on, right? Now, what is JSON? JSON is a JavaScript object notation, very widely used, very simple yet powerful. And even our Amazon Dynamo, Amazon Dynamo was plain text, but they now have moved it to JSON format at Amazon. So it's a JSON is a like very popular one because your browser understands it. Almost every tool understands the JSON format. You don't require when you are representing some object as JSON format, you don't require any parser or anything. In case of a browser, it quickly gets parsed. You don't need a separate newer kind of parsers. There are hundreds of programming languages out there in which which understand JSON and which can create a JSON. So that is why a JSON is really very good choice of design at MongoDB. And the name that MongoDB came from, can somebody tell me quickly the history behind the name? Why is it called Mongo? Okay, not really. The word Mongo comes from humongous. Okay, humongous. Right. Looks like Google is down. Right. Uh, Not really. Not really. JSON does not have any size limitation, but the amount of data which is represented in JSON is little more than the standard one, little more than the other formats, but it is lesser than XML. So, but JSON does not have a size limitation. The size limitation will come from the tools that tries to handle JSON. It will be their limitation. Philosophically, JSON as a format does not have any limitation. Now, we'll just jump into what it is in the, so we are actually going, over the MongoDB, internals now. Okay. So one of the properties, so here we talked about what is MongoDB. A MongoDB, which is a document oriented database. A document is a JSON kind of format. And second is MongoDB supports replication. Okay. MongoDB supports replication in this format, right? So there are, when you are creating a MongoDB cluster, you have various kinds of nodes. So you take one of the computer and say, this guy is my primary computer, okay, on which you install your MongoDB and tell, okay, this is my primary. And then you define something called secondary. You tell this computer is my secondary. Now, whenever people are reading, they can read from secondary, but only primary can only take the writes. You can only write to primary server. Okay. So this kind of arrangement of primary and secondary is called a replica set. Okay. The objective of a replication or a replica set is high availability, failover and backup, and automatic failovers, and these properties of these circumstances. But primary and secondary are going to store the same data. It will be complete data replication. Here, there are three copies of the same data. One copy lying at the primary, two copies lying at the secondaries. One here, other here. That means that primary and secondary, these three, we are getting 1/3 of total storage, but we are getting 3 times of replication. Now, in case this second, so whenever there is your client application, which is and driver, so client application is talking to system via a driver, a request to read comes in, it it would directly go to secondary, and client will read from it. Now, in case this client need to write the data, he will go to primary, and this data will automatically be propagated by MongoDB from primary to secondary. So this composition of this way of arrangement is called a replica set. A replica set has two kind of computers in on a vague level. One is primary, a secondary, and primary does the writing while secondary provides the reads. And by default, in the default installation, it's the primary which does the reads and writes both. Okay, but in case of production, you generally make your reads from the secondary one. Also, okay, those kind of details we'll go more and more detail more and more into details after some time. Okay, now I've got some questions. Why two secondaries just for reading? How many secondaries can we have? Can you guess? Give me a guess, just a random guess. So n number of, perfect, perfect. And what about Wahid? Why two secondaries just for reading? Just guess. Just give me any guess. Anybody else can guess the answer? Why do we have two secondaries just for reading the data? Right, right. So basically, you can have any number of secondaries, and there would be only one primary, though. Okay, there will be only one primary and any number of secondaries. And whenever one secondary goes down, you can get the data from the other one, and so on. Okay. Now, a question is that who selects the primary? Who makes somebody primary? If it is you who is doing that, then every time primary fails over, is it you who will be again go and change the servers? Will the system stop functioning till the point you are replacing a server? So if you do that, that means your system will be completely dependent on you, and in case you went off to sleep, then you are not serving to the customers. So there has to be an automatic failover, and that failover is based on elections. So MongoDB has this beautiful way of elections where one computer, each of these nodes, they give their votes to the other people. Okay, they provide that this guy is more based on, and all of these computers, they keep on pinging each other every 10 seconds, and based on the response to the ping, they give their votes. So if next time, if primary did not respond to the secondary, secondary will give less votes to it, and then after a point in time when primary loses the votes, it has to step down, and the next node, which is more popular amongst the cluster, will get elected. Okay, so it is standard election way where all these three are the candidates to become primary. Okay, and each of these three is voting to other person, just that they are not cheating. Okay, just that they are not cheating in the sense that they start favoring somebody. The voting is strictly based on the ping responses. How much time did it take to respond? How much data packet loss was there? And so on and so forth. So this election decides who becomes the primary, who remains the secondary. Okay. Any other questions? Quick questions? Just a second. Okay, we have got very interesting question. So this voting happens when a node goes down. Not really. Yes, yes. Very interesting question. So this voting happens only when a node goes down. No, the voting can happen in cases when there is no response. Basically, there is a computation which happens when a node becomes inaccessible from the majority. Okay, from the majority says that this guy is no longer behaving properly. That moment of time, replica set forces a node or node automatically steps down. Okay, it's both the same thing whether replica set forces or they themselves step down, because in case a machine is completely non-responsive, that means external it will be anyway be forced to step down. Okay, so what if primary is temporarily down and secondary did not receive any? In that case also it will step down. Who oversees the responses? It is centralized. No, it's not centralized. So every time election, basically election happens, they happen in a replica set. Okay, in the whole replica set. Okay, right. And each node, yes, Anuj, you are right. Each node records the responses, and they keep on making a note of responses from the system. And the moment they notice any irregularity from the behavior of primary, the primary will be forced to step down. Okay, so this diagram shows that in here the primary was stepped down, and then the second one of the secondaries became the primary. Look at this. And the way the nodes are communicating is called heartbeat. Heartbeat is a general term used in such case of scenarios. Okay, so this is what it is. Any questions? Any other questions right now? Otherwise, move on. Great. Now this is replica set. This was replica set where all the nodes were storing the same data, right? Which means that in case you have got a storage limitation or load limitation, you want to divide the traffic you want to divide the data. Now what do? How do you divide the data? Because maybe the same data, say you are having 10 petabyte kind of need, cannot be stored on a single node. That is why you combine these replica sets which we discussed earlier. You combine these replica sets. Okay, so Anuj, your question is regarding who initiates the process of what? Okay, okay, great. Let's move on. Now, what if your data is huge? You are not able to store the data on a single machine. So what you do is you take multiple such replica set as described in the previous example and make them stand in the line. Yeah, sorry, in the queue. How should I describe? You can say that you take multiple such replicas and and store your different set of data into them. Okay, So let's say you have got some 10 terabyte of the data which you need to store, or you can think of, let me explain. So let's say you have got 2 GB of data, 2 GB file, 2 GB movie file you have got. So what you do is you take this 2 GB file from 0 to 1 GB, you give it to one computer, or from 1 GB to 2 GB, you give it to the another computer. Okay, you divide it into two portions, and this this could each of 1 GB could go to an individual computer or to a replica set. Okay, so replica set is nothing but one computer multiplied multiple times. So for the reliability reasons, for the backup and failover, and for the load sharing, and this dividing of the file into multiple nodes or multiple replica sets is called sharding. Sharding means slicing a data into pieces and putting it in a different set of computers. So this is called sharding. So the way it happens is that the architecture looks like this. You have somebody called router. Router is who? The sharder. This is the guy who is the sharding server. Okay, so the request from the users will come to one of these. So you have also done a load balancing at the level of sharding server. So one server, another server. And both of these servers are talking to multiple shards. So the data, and since we talked about key value pairs, so every when the request comes for, say, uh, for a certain data which is stored in the first one, it routes to the this first one, otherwise it routes to the second one. So the job of slicing the data and putting it into each of these nodes, these shard, replica set, or machines, this is what the same name here. Similarly, there is something called config server. These config server keep on making note of that which ID, which piece of data with what identifier went to which shard, shard 1 or shard 2. So in general, if you remember our first problem where we were building this terabytes of movies store, so this config server is what somebody said list. We need to maintain an index that which movie is stored in which server. This is the role of config server. So you store that information in config server saying that this file is going to go here, going to go into server 1, server 2, and this call is being taken by MongoS. MongoS is the guy who is talking to the public, who is talking to the users. Whenever users are making a call, they are making a call to your MongoS. MongoS takes it and checks with whatever request is coming, and checks with config server where should that request go, and it sends to that one shard. Each shard could be independent computer or node with a MongoDB installation, or it could be a basically replica set in which there is a backup, primary secondary system everywhere. So this is a typical way automatic sharding works in case of MongoDB. Okay. So now let's say I have got a quick question for you. Let's go back here. Okay, just a second. Look at this diagram. It has got two shards. Okay, let's imagine each shard has got one primary, one secondary. So there are total how many computers? One, two, three, four. Each shard has got two computers in it, and each computer has got one terabyte of hard disk. So effectively, how much data will you be able to store? Anybody? So you have got two shards. Each shard has two computers, one primary, one secondary, and primary is of 1 terabyte as well as secondary is of 1 terabyte. Okay, so effectively there are four computers and 4 terabyte space. Perfect, perfect. So everybody is almost correct. Okay, So Wahid, I need to should I explain again? Okay, okay, you got it, you got it. Great. Okay. So we effectively got 2 terabyte as the outcome because each shard gives us 1 terabyte only. Okay, great, great. So that is how it works like. Now let's talk about full index support. Now, unlike the olden days where the database only provided you the indexes on plain text and it provided you with a hmm, it provided you with the support of say numbers search indexing on numbers, indexing on say boolean fields, numbers, and in normal strings. Okay, but it never provided you efficient search. Efficient search, when I say, it means that any word that exists in a text box, you should be able to search upon it. But MongoDB provides you really, really great form of index supports. Okay, so index support as in you in my first example here, not this one. So if I have to search for education.graduation is IIT Roorkee, then you can search very easily because MongoDB helps you in creating index this way. You can create an index on education.graduation or likes.music. Similarly, you can create index on name, skill, likes.music, likes.sport, education.graduation. So it provides you very granular uh, index support. And it provides you a geospatial kind of index support. As we talked about graph search, so half of the problems related to graph search are with respect to geographical searching, such as, I mean, all of you might be using an application called Zomato, right? So in Zomato, you can say that find restaurants within this much of radius around me. Now imagine that there are millions of restaurants or you are looking for people who are living around you. To search amongst billions of people for thousands of people around you is really really difficult game because you'll have to look for this let long. So MongoDB provides you really really great uh, geospatial one. Yes, yes. So type of free text index, yes. It provides you a very good in free text support and multiple languages. So example of geospatial searches are restaurants within 5 kilometer radius, people living in this boundary. You draw a boundary and say find out all the people. Say you are given a billion people's data. Where do they live? Exact coordinates. And now you have to tell that who are the people, how many people are living in this boundary. So that kind of questions can be answered with geospatial indexing. Now third one is text searching. When you think about text searching is a very complicated task. It requires you to index the word, find out the word out of the complete text, and then it also needs that you need to be able to search for say work and working. When somebody is looking for work, you should be giving answers for works, meaning plural, as well as working, worked, and so on. So this kind of extension of a word is called stemming. So there are multiple algorithms for stemming, and MongoDB provides you the stemming on all kind of words. Stemming algorithm is implementation is there in MongoDB. And language support, so you can search in Hindi or in your local language. Okay, it provides you an exhaustive language support. And there is something called stop words. You should not be able to search on certain words like the and those common words it removes, those are called stop words. Okay, this is pretty much with respect to full text index supporting. Now there is a great concept called MapReduce. So MongoDB is one of the few databases which provide you with the MapReduce paradigm. What is MapReduce? MapReduce is a paradigm where you write your code in terms of individual units called map and reduce. Now you once you have finished writing your code in those execution units called map and reduce, you hand it over to MongoDB. MongoDB will take it closer to the data and then execute it and brings you back to the results. Now it saved a lot of headache because transmitting the data is a very big pain. And transmitting so much of data is not possible at all in lots of cases. That is why a map and reduce is required. So the way it happens is, so here you see this person is submitting a job to a node. Node has taken this logic and put logic in three forms. Okay, three kinds of, basically say you want to execute a logic which is stored on three machines, whose data is stored on three machines, these three say. Now it will make three copies of the logic of MapReduce, this. There are three copies of the same logic. This logic is sent to these nodes, first, second, third. And once this execution finishes, this logic execution finishes, this data which is generated here as a result of application of map is then combined together, and here the reducer is executed. Okay, so in case of MapReduce is a paradigm whereby you write two functions, one is map, one is reduce. In case of map, you break down the input into a format of ID and value, and give it to the system. Now system, which is MongoDB will take your ID value from each machine and then will order these ID values by ID and then feed it to the reduce function of yours. So basically, in case of reduce, you will be reducing the values into a single value, while in case of mapper, you will be converting the input into key value pairs. Key becomes the identifier for the row. Okay. Now this is little difficult to understand in first go, but do not worry about it because we'll have a lot of exercises on MapReduce. I know that it is, I mean, I'll not be doing a justice if I say that I have explained enough. Okay, so that is why we have kept a complete separate session from beginning to end for these kind of tasks. Okay, but let me again try. So when we do group by, do you remember doing group by? I'll just type it for you. Now let me increase the font to big. Now say you have a group by, select name, or let's say select ID, comma, say average, and here average salary from employees, group by ID and salary. Okay, now what does it do is, here if you look at this, what it first does, it first takes the ID from here because we have said group by, and whatever input is there, it groups all the values belonging to the same IDs together. Okay, and then whatever grouping has happened, out of that group it applies the average on top of that one. Okay, so it did two things. One is application of a, a function called aggregate function, which is average in this case. This is logic of average will be going in your reduce function, while defining that I want to group by this ID goes in your map function. Okay, so basically mapper says this is my ID on which this input, and this is my ID and value, and on the ID please group my data, while the reduction is whatever group after grouping, the reduce function will be run on those all values belonging to same ID, and hence the average, and after grouping them together the average will be computed. So this is the standard way of thinking the in terms of MapReduce. But unless I give you more exercises on MapReduce and show you couple of more examples, you will not be appreciate, you will not be able to appreciate this. So just to emphasize again, a MapReduce paradigm is very well supported by MongoDB. Okay. Now there is another paradigm for querying. So why these things I'm explaining? Because there is no select star from XYZ kind of SQL query supported from MongoDB. MongoDB does not support standard SQL. Okay. The only way it can support SQL is via a tool called Hive. Okay. That too is very unreliable. Okay. Which means that you will have to understand MapReduce, as well as you have to understand something called aggregation pipeline. Aggregation pipeline is a combination of SQL with a combination of SQL plus Unix pipeline. How many of you understand what does it mean by Unix pipeline? Hmm? Okay. Who understands what this means by Unix pipeline? Okay. Never worry, never worry. So this is basically a way to say that in Unix, when we say that output of one file goes to the second one, and the second one's output goes into the third one, that is what is known as pipelining. Actually, pipelining is there in the DOS also and in Windows. Okay, whereby the output of one program is fed as input to another program. Similarly, we have something called aggregations in case of MongoDB. Here, there are various kinds of operations you do on the data, like project, match, group, sort, similar to SQL, and the output of one is fed to another one, and so on. Okay. And yes, as Samir says, it's a sequence of tasks to do. Just that in this sequence, the data from one output goes to another one, and so on. And this is how a Unix pipeline on the face looks like. You have an aggregation is basically an array. You see the square bracket? They say that it's an array of what? This. Meaning the output, and this is a single aggregation phase. This is a single aggregation phase. This is a single aggregation phase. Okay, so first one is match is equal to select, saying where status equals A. So out of these documents, it will select only the documents with the status A, and then this is what is generated. It is fed to the group now, this second section. Now group will do is group on what? Customer ID. This is customer ID, right?
Now, and after doing grouping, what you need to do is sum all the values in amount. That is why it has grouped by 123 and summed up 500 plus 250, which is 750, and so on. So this is just a very, very cursory look at aggregations. But you are not still qualified enough to say that you know aggregations. Okay, right. So this is a simple example of aggregation. Okay. So it provides you an aggregation pipeline to do a lot of tasks. Okay. Now the next feature which is provided by MongoDB is for storing very large files. Okay. As a lot of people asked in the first section, so the purpose of GridFS is basically providing an interface to store the binary data, and that too very huge data. Okay. So as we told that everything you store in a MongoDB, just like you have rows in database, you call those that kind of unit for each one is document. So you insert document, update documents, you delete documents, you query documents, similar to databases where you have insert rows, delete rows, update rows, and so on. Similarly, and when you talk about grid file system, where you want to insert binary data, you basically do is you create small documents out of the whole file. After you have sliced this data into small pieces, like a bit of a chocolate, you have, so each of this bit is going to go into the one system, right? And each of this is a document. Each of the small piece is a document. So grid file system is really useful to to help you make a service like YouTube where video streaming such, because you require to jump to a particular location in a video, right? And when you have divided this whole file into pieces, means that you can now jump to a particular piece very quickly. Okay. And you always have a multiple choice. You always have a multiple choice of machines from which you can read this. So this is what is GridFS. All right. Now here I want to go ahead and show you how does Mongo look like. Okay. And also as an access, as we will be providing you a cluster called cluster based system. Let me, it's too big for me, right? Now we have got clusters called MongoDB dot MongoDB dot so I'll show you. So SSH dot MongoDB dot MongoDB1 dot KnowBigData dot 1. Mon- so MongoDB, okay. Anyway, that I don't know the password right now. So to run Mongo, I have installed already on my machine. Okay. I've already installed on my machine locally, but you don't need to install MongoDB locally. We'll be providing you a cluster where first, if for first few session, you will be experimenting with the pre-installed one, and at later point of time, we will be providing you with the fresh servers where you will have to install it and prepare your replica set and sharding systems. Okay, now here let me just show you how does a Mongo look like, right? Before I move on to hands-on, do you have any questions? No questions? Okay, excellent. So let me increase the font so that you can see. Now, since I have already installed Mongo on my machine, I have got a command prompt called Mongo. See, this is the standard way you, this is the command prompt of Mongo, right? Can you guys see the screen, or should I increase the font? Okay, so here I say, what is the first command? First command is Mongo, then so DB is use DB, so collection. And here again, as a quick recap, in RDBMS, what you call a table is nothing but a collection here, and a row is a JSON document, index is index, joining is embedding and linking, partitioning is sharding. So here for time being, understand that whenever I say collection, you should think of in terms of a table where you are putting all the, and when I say document, it is nothing, you can think of it as like object, or you can think of it as like a row. Okay, now, so I say so DBs. Okay, and if I say DB, then it shows me my DB. If I say DB, it shows my DB, which is test, and I say show DB, and now I say use your caps, or I can say pure profile. Even if that database does not exist, you can say this. And now whenever you create a document, this pure profile database is going to get created. So I'm going to say that uh, I say a collection called hello world, db dot my hello world, and say find. It says no records find. Now I say insert, okay, and I say, now I say name equals Yogesh. So I've created an object with a key called name and value called Yogesh, and I'm inserting this object into a collection called hello world. Okay, hello world dot find, and there you are. There is this object. It has got an ID automatically created and name as Yogesh. Perfect. And you can again create same data, and you can see this, right? So this is how an object looks like, or a row looks like. This you can think of the curly braces start, curly braces end. This is an object. Okay, from here, here to here. This is an object. Okay, and it has got a property called name, and the value is Yogesh. ID is the unique identifier for each row. It is automatically generated if you don't provide one, right? So this is pretty much from my side. Do you have any questions? Okay. So when object is created, it is based on lots of things. One is timestamp, process ID, and some other more parameters. And this is fairly, object ID is an object here. Here it's an object. Basically, the way here it is an object representing an ID. Okay. Okay. So it's a way of saying that this is an object which is there. Yeah. If you can put an underscore ID column, that means that you are forcing and you know what you are doing. MongoDB assuming that you know that you want to keep this as ID, and that value will become the identifier for that row. And in case you are trying to again insert another ID with the same value, then it will throw an error. Let's just show you an example. So if I say underscore ID colon 1, it gets inserted, and say db dot hello world dot find. See, it doesn't have a object in this. Okay, it has an basically it doesn't have an object because we specified it specifically. And then if you try to do it again, it will throw an error. It says caused by some error number, duplicate key error. Okay, which means you are trying to insert an ID which you already inserted. I tried to insert again a document with ID colon 1. All right, so hope I could explain, Kamlesh. Great, great, great. So any other questions, guys? So next is that who uses it? There are hundreds of people who are already using it. Is MongoDB has any type? Yes. So when you're defining JSON, you are basically telling that my value is of such and such type. Okay. And the whole JSON is composed of, at the end of day, numbers and strings and a combination of those. Right, right. So here you can say, when you say here like this, and you can say ID colon 1, and you'll get to Yogesh here. Got my point? How to find first record using ID in where? You got the ID, right? So where ID colon 1. And in that case, if you are trying to look for, say, this one, okay, this one. So if you put it here, what will happen? You'll have to, okay, this gives nothing. So you'll have to put a object ID here. You say object and then ID, and then see this. So when you are specifying a ID, automatic generate ID, then you specify it this way. Okay, you have to put object ID then brackets in that. Okay, so it's a key values. Yes, you can always, the way you think in terms of object oriented programming, you have a field name and you have a field value. Similarly here, it's the same, exactly same phenomena. It's called key, and the value could be a composite object or a plain vanilla values. Right. Now, where is my presentation? There. Right? Is there a way we put auto increment number as ID in? Yes. So that will be an exercise in the second assignment, and that is why I don't want to disclose it. But I'll explain to you when I'm explaining that problem. So it is possible to make an auto increment system using MongoDB. Okay, it is definitely very much possible. Okay, so who uses it? There are hundreds of use cases of MongoDB all across. MongoDB is used not only for handling big data, but also for the normal smaller data, because it provides you a very, very smooth way of presenting an object and persisting an object, right? So any object, any Java object, any kind of object you can create and convert and persist it as a JSON, and then you can search it and then and get it. Because in case of a relational, if the same table has to be presented at multiple ways, then it becomes extremely complex. Okay, In those cases, when you don't want to keep on creating objects from relational databases, people generally end up using MongoDB. And MongoDB is also used as cache server for lots of systems where there is too much of relational database and lot of things are need to be joined to create objects. People end up using MongoDB as cache, meaning a cache. You can store the data temporarily into it. So there are lots of use cases for MongoDB, and these are the various industries and sectors being used. Okay. Now here, this is how your sessions will look like. Today's session, the video will come here, the schedule will be here after logging in, and here the presentations, quizzes will be there, and each session wise we'll keep on uploading these details. Okay, so make sure that you go through the installation instructions. Here you see this section, just under the video or maybe above the video there will be something called installations. The LMS will be updated in an hour's time, and then you can start using that one. Okay, the video may not be uploaded immediately. Video uploading will take some time. Okay, so hope I was able to explain to you. This is LMS and you can use that one. So pre-work for you for tomorrow is that install MongoDB based on installation instructions in LMS. Okay, and try these simple commands: so db, so collection, and there will be a quiz also. You'll have to complete that quiz. Okay, so these are the assignments for tomorrow's class. And for further references, use MongoDB manual, and these are the further for reading this. If you want to gather more details about NoSQLs and big data, you can go there. Okay, tomorrow we'll talk about installation getting started and normal CRUD operations. Okay, so but before that, start working on the quiz and installation instructions, which will be updated very in an hour's time. Okay, feel free to reach out to me in case of any questions. So that's pretty much for today, and I hope you guys enjoyed it. See you tomorrow then at the same time, and probably the URL for the meeting will remain same, and I'll check it again. Okay, so the URL most likely is going to remain same, and then see you tomorrow. All right. Okay, bye bye. Bye bye.